along with your IIT foundation preparation, and also it would give you a very good revision for your school curriculum. With this, I would like to quickly introduce myself. This is Trishita Majumdar here, and I'm a teacher expert at Cuemath with a teaching experience of 4 years. The subjects that I cater to is mathematics and reasoning, and the regions that I teach is India and US. With this, let's look into the table of contents for today. So we are going to quickly look into the table of contents for today. So we'll understand what do we mean by linear equations in two variables, its applications, problems, word problems, and learning outcomes. So with this, let's quickly look into the definition of two variable linear equation. An equation is said to be linear equation in two variables if it is written in the form of ax plus by plus c is equal to 0, where a, b and c are the real numbers and the coefficients of x and y, that is a and b respectively, are not equal to 0. Okay. One more thing about two variable linear equation is very important, that the degree of the equation has to be 1. I'm sure that most of you must be aware of what you mean by degree. It means that the highest power of the variables has to be 1, and also along with that you cannot have more than two variables or lesser than two variables. You have to have an equation which is exactly a two variable linear equation, and along with that you cannot have negative powers on the variables as well. Okay. So these are some key points to be noted down for the definition of two variable linear equations. With this, we'll quickly move ahead with our solution of linear equations in two variables. So if you all notice here, it's told every linear equation has a unique solution as there is a single variable in the equation to be solved. But in a linear equation involving two variables in the equation, a solution means a pair of values, one for x and one for y, which satisfies the given equation. What does this mean exactly is, whenever we have a simple linear equation, let's say 2x plus 3 is equal to 0, in such cases we just have one solution to this equation as it is a one variable linear equation. But whenever we have two variable linear equation into picture, let's say 2x plus 3y minus 3 is equal to 0, that's when you will have the solution existing in pairs. In pairs as in terms of coordinates, okay? You will have pairs of x and y. With respect to every x value, what's the value of y? So both of those pairs of the points is going to lie on the graph. Okay, so that's how you find out the solution of the graph. So we are going to go ahead with the graphical representation of two variable linear equations very soon. Okay, so with this, we'll quickly go ahead with our next thing, that is an example of a two variable linear equation. Let's see. Here we have a function which is given to us, that's 2x plus 3y. Okay. Now let's say that this 2x plus 3y is equal to 0. So can anybody tell me what are the, you could tell me two pairs of solution to this particular two variable linear equation. All of you can comment on the comment section and let me know what are the two pairs of solution to this particular equation. And it's not necessary for all of you to have the same solution, as you may have infinite points on these. So you can take your own values of x and calculate the respective values of y, and let me know all of your solutions that you get for this particular equation. And then I'm also going to tell you on how do we go about these questions. Okay. All right. So let's wait for all of you to give the answers. Any responses? Let's see. Okay. All right. So let's see how do we go about this question. So here, if you see, you have 2x plus 3y equal to 0. So if I have to find the first pair, I can take any random value of x. Okay. So any random value of x is fine. So you could take anything. Let's say that I take the value of x as 3. Okay. So I'm going to take the value of x as 3 and I'm going to calculate the respective y's value. So what am I going to do is, I'm going to this equation and I'm going to substitute x equal to 3 in place of the values of x. So 2 times of 3 plus 3y is equal to 0. So from here you have 6 plus 3y is equal to 0. And here you would have 3y is equal to negative 6. So y is equal to negative 2. Okay. I hope this is clear to all of you. So this was 2x plus 3y is equal to 0. So we got y is equal to minus 2 for x equal to 3. As in, I could say that my first pair of solution is nothing but 3 and minus 2. Okay, everybody clear with this? So for x equal to 3, we got the value of y as minus 2. Now the question is, isn't that always we calculate the value of y by assuming values of x? No, there is no such rule. You can also do the other way around. You can also calculate the value of y and get the value of x. Okay. Alright, so is there anybody who has got any other kind of solutions? I'm going to solve for one more by taking the value of y. Okay. So as you all can see that if I take the value of y as, let's see. If I take the value of y as 4, then let's see what's the value of x we get. So 2x plus 3 times 4 is equal to 0. So 2x is equal to minus 12. So x would become equal to minus 12 over 2 and that is equal to minus 6. Hence we get the value of x as minus 6. So for the value of y as 4, we have got the value of x as minus 6. Hence the other pair of solution which we got is 4. Sorry, not 4. We have to first always write the value of the x coordinate. So what will we have here first? We'll first have minus 6 here. Minus 6 comma 4 would become the answer. So hence these are the two pairs of solutions which we could calculate from the given linear equations in two variables. Okay, I hope this was clear to all of you. So with this, I would be quickly taking you ahead with our system of linear equations wherein you have different categories to be checked. Okay, because if you have two different linear equations given to you, you may notice that the two graphs of the equation might intersect at one point, or they may have several solutions in common to them, or they might also be parallel to one another. In that case, they will not intersect at any point, no matter however, whatever extrapolation you do. Okay, so even if you make a lot of extension to it, they will not intersect. Those are the cases of parallel lines or no solution cases. So we are going to look into all of these three categories and I'm going to write all the three conditions for each of these categories. I want all of you to focus and also make a note of it because this is something which is going to be very important when it comes to problems of two variable linear equations. Okay. Now here goes our first question. First statement. So if we have something like this, a1x plus a2x, or let's say a1x plus b1x, a1x plus b1x, b1y is equal to c1, and this is a2x plus b2y is equal to c2. These are the two equations I have taken into consideration. This is equation number 1 and this is equation number 2. So the first thing which I am going to write is for unique solution. When I say unique solution, it means that the graphs of these two equations is only going to have one common solution, which is at the point at which the two graphs are intersecting. Okay, so the point at which they intersect, that coordinate or that solution is something which is common to both the graphs, both the equation 1 and equation 2. So how do you verify if the system of linear equations have unique solution or not? You can always see a1 over a2, you can calculate the ratio a1 over a2, b1 over b2, and if these are not equal, then you could say that it's a system of unique solution wherein the two graphs would only meet at one point, at one common point, which is the unique solution to them. Okay, this is the first case. Now coming to the second case, that is for infinitely many solution. Infinitely many solutions. It means that the two graphs can have many solutions over it. Okay, so you don't have any limitation to it. Infinitely many solutions, and for this, how do we go ahead with it? So if you all see, here you could notice that we had a1 over a2 not equal to b1 over b2. For infinitely many solution, we will have a1 over a2 should be equal to b1 over b2, and that should be equal to c1 over c2. I hope this is clear to all of you. And the third category of system of linear equations is nothing but no solutions. No solution is also the case of parallel lines, you could say, or You could say these are parallel lines. So if you've noticed, in case of parallel lines, if you just think about drawing two parallel lines, how do they look like? They look like this. No matter how much ever you extrapolate them or you make an extension, they would never intersect at any point. And if things do not intersect, if these lines do not intersect at any point, I could simply conclude that they don't have any equation or any solution in common to them, right? So this is the case of no solution, or you could say basically your parallel lines, okay? So the case for this would be A1 by A2 is equal to B1 by B2, but this should not be equal to C1 over C2. Okay, very, very important these three conclusions are. I want all of you to take either a screenshot of it or make a note of it in your notebooks. I'm sure that most of you must already be aware of this because you must have learned it in your school syllabus, but still this is a kind of revision for all of you. So please go ahead and make a note of it because we are going to use it for our questions in some time. Okay, all right, so hope everybody is clear with all of these. So with this, I would quickly take you ahead to the next part, that's graph of a linear equation in two variables. So let's see here what's written. So it's told that every point whose coordinates satisfies the equation lies on the line. Every point on the line gives a solution of the equation. So it means that if you draw a particular graph and there's a point lying on the graph, it means that that particular values of x and y or that particular solution and that particular coordinate is the solution to that given equation. Okay. Any point which does not lie on the line is not a solution of equation. Okay. I hope that's clear to all of you. So with this, we are going to go ahead with an example to quickly understand this. And let me give you an example here. So we are going to take an example of, let's say that 2x minus y is equal to 4. Okay. So this is our equation and we are going to plot this on the by using graphical method. Okay. So just notice the steps that I am taking you through. Okay. So this is the first equation we have. Now, as we all know, how do we calculate the pair of solutions? We have just done some time back. All of you can calculate your own pairs. So I'm going to do it here. So let me just take two different pairs. Okay. So let me say that this is the value of x and this is the value of y, and this is going to be the value of x that we assume, and with respect to that the value of y. Okay, so the first thing that we are going to do is we would be assuming the value of x to be 0. So with the assumption of value of x to be 0, we have to calculate what's the value of y. So when we put down x as 0 here, so 2 times of 0 minus y is equal to 4. So from here I could say minus y is 4, so y is equal to minus 4. So I could see that for x equal to 0, my value of y was minus 4. Okay. Now with this we are going to do a different pair again, because if you want to draw a graph of a linear equation in two variables, you will need definitely at least two pairs of solution. Okay. You could also go ahead with more than two pairs, but it's fine to go with just two pairs as well. This time I'm assuming my value of y to be 0 and calculating the respective value of x. So 2x minus 0 is equal to 4. And if any of you have any answers, please put it up on the comment section. So 2x is equal to 4 and x value is equal to 2. So we have got the value of x as 2. Make sure that you're taking care of the coordinates of x and y's order. Okay. So now I know that my first solution is 0, minus 4 and my second solution is 2, 0. So accordingly, I will now make a graph of this. Okay. So here's my graph. So this is going to be my x-axis. This is going to be my y-axis. If any of you have taken other values of x and y and have got other solutions, it's completely okay. All you have to see is that your line is the same line, no matter whatever solution you've got. Okay. It has to lie on the same line. All right. So let me just make the markings. So we know that in y we have to go till minus 4. So this is 1, 2, 3 and let's state it here minus 1, minus 2, minus 3 and minus 4. And in x we'll go till 1, 2, 3 and here we'll go with minus 1, -2 and -3. Okay. Now let's quickly plot the points. The first one is 0 and -4. So this is our origin 0. So 0 and -4. 0 in the x-axis and -4 on the y-axis. -4 on the y-axis would be this point. Okay. Any point on the y-axis, value of x is 0. Any point on the x-axis, value of y is 0. Okay. So that means now for the second point 2 and 0, we will have our point lying here. So we have got our 2 points. Now all we have to do is just join these two. So we are going to have a straight line. So this is actually going to be a straight line. Let me again draw. So this is going to be something like this. And the equation could be written above it. So the equation here is 2x minus y is equal to 4. I hope everybody were clear with the approach on drawing a graph. Now with this, you may have a lot of questions that is majorly asked in your school syllabus. We are not going to do much of graphical questions in today's class because today's class is majorly going to be more of objective questions. Okay. So this is majorly a revision for your school curriculum as well. So if you want to, if there's another equation given to you, you could do the same method for that equation as well, and you can try to plot it in the same graph. Okay. So graphically also you will be able to figure out whether a given equation, whether two given equations have a unique solution, have infinitely many solutions, or have no solutions. Okay. And theoretically I have already taught you how to go about it. I hope everybody is clear with all of these. Now with this, we are quickly going to go ahead with our applications. So as you all can see, applications of linear equations. So it is useful tool for comparing rates of pay. It's used to make predictions about what will happen in future. Yes. Monthly sales, power consumption, calculating speed at variable rates. So calculating speed at variable rates, calculating slopes, all of these are some basic applications of two variable linear equations. With this, we would be starting with our problem. So here goes your first question. I want all of you to give it a try and put your answers on the comment section. Okay. Until then, I'll also be solving this. How many linear equations in x and y can be satisfied by x equal to 2 and y equal to 3? And here goes your options. Only one, only two, infinitely many, none of these. Okay. Any answer? All right. This is a pretty simple question. As you all can see, they want you to tell how many linear equations in x and y can be satisfied by x equal to 2 and y equal to 3. So x equal to 2 and y equal to 3 basically denotes that the coordinate is 2, 3. And we know that to form one specific line, we would need at least 2 points. But here they have just given us one solution, x equal to 2 and y equal to 3. So it's very obvious that you can have more than one lines passing through that point. You can have infinitely many lines passing through the same point. Like there is no limitation to it. Okay. I hope that's clear to all of you. Definitely I cannot say it is just one or just two, but it is going to be infinitely many because through one point you can have infinitely many solutions, infinitely many lines. Let me show you. So this is a point. So you could have lines like this, like this, like this. So yes, so like this and then this. So this keeps happening, right? You can see that from one particular point you have many lines passing. Hence, the answer to this particular question is infinitely many. That's it. Okay. So with this, we'll quickly go ahead with our second question. Here goes our second question. The graph of y equal to 6 is a line. Now, you have to tell the nature of it. So that line is what kind of line? So please go through the options and let me know what's the answer you're getting. Any answer, anybody? Well, this is going to be very simple. As you all can see, the graph of y is equal to 6. Now, how would a graph of y equal to 6 look like? And first of all, let me first represent y equal to 6 in terms of coordinate. So as I told you, if you remember some time back, I was telling you, any point that lies on the y-axis, the value of x coordinate is going to be 0. That means if you have a coordinate axis like this and if y equal to 6 is at this position, then my line would simply be like this, which is nothing but it is passing through y equal to 6. So what can I conclude from here? I can conclude that the line is going to be parallel to the x-axis at a distance of 6 units because this is 0. So my answer to this is option A. Now, what if I would have changed this question to x equal to 4? What if the graph of x equal to 4 had to be represented? So it's very similar to this. So I have my x and y coordinates, x and y axis, and then x equal to 4 would be here, and my line would be passing on through x equal to 4. So it would be parallel to y axis at a distance of 4 units from the origin. I hope that's clear to all of you. Yes, all right. So with this, we would be quickly going ahead with our next question. Here goes our next question. If AM is equal to BL and BN is not equal to CM, then the system of equations has a unique solution, has no solution, has infinitely many solutions, may or may not have a solution. So let's see who gets the answer to this. We have already studied about several conditions of a system of linear equations. So please take that into account and try to solve this question. Any responses, anybody? Okay, all right, let me take it forward. Okay, I can assume this to be, let me not write it down here, let me write it down here. I can assume this to be a1 of x plus b1 of y is equal to c1, and the second equation is a2 of x plus b2 of y is equal to c2, right? This is my second equation. So from here, if I have to check through the conditions of unique, infinitely, or many solution or no solution, I'll have to figure out the ratios a1 over a2, b1 over b2, and c1 over c2. Okay, so these are the three things which we would be needing here. As you all can see that if I calculate a1 over a2, what's a1 here? a1 is a here and l is here. So a1 over a2 can be written as a over l. Okay, and b1 over b2 is nothing but b1 over b2 is nothing but b over m. Correct? B over m. And from here, if you see, the first condition that's given to us is that am is equal to bm. am is equal to bm, that means I could say that if am is equal to bl, so from here I could also say that a over l is equal to b over m. A over l is equal to b over m. And you see here that a over l and b over m are nothing but the ratios a1 over a2 and b1 over b2. So one thing which we have figured out from here is that a1 over a2 is equal to b1 over b2. But now we have still not got any solution to this, because if it had to be unique, then this had to not be equal. But now we need to check whether, now unique cases anyways excluded. Now we have to either check for infinitely many or no solution. And that could be only calculated if we go with C1 over C2. Okay. So now let's calculate what's our C1 over C2. So C1 over C2 is nothing but C over N, which is here. And if you look into the other condition that's given to us, Bn is not equal to Cm. So Bn is not equal to Cm. Or from here, I could also say that B over M is not equal to C over N, right? So from here, if you see, you could see that B over M and C over N are these two ratios, B1 over B2 and C1 over C2. So what can we conclude from here? We can conclude from here that B1 by B2 is not equal to C1 by C2. And the conclusion from the first statement was A1 by A2 was equal to B1 by B2. So when we jot down these together, if we take this as equation 1 and if we take this as equation 2, then you could say that A1 by A2 is equal to B1 by B2, which is not equal to C1 by C2. And this is a condition for no solution or parallel lines. Okay. Hence, option B is the right answer to this. I hope this was clear to all of you on how did we go about the question. Just write it in the general form and go about finding the ratios. I'm sure you would be able to do these kind of questions. Okay. Alright, so with this, we are quickly going to go ahead with our next question. And if you're enjoying the session, please do click on the like button and do share it with your friends. Okay? Alright, so here goes our next thing, that's on word problems. So here goes our first word problem. I want all of you to focus on this and tell me the answers. Okay, so if you all notice, let me also put down the options, okay? So if you all see here, it's a question on the boats and streams, okay? A boat goes 32 kilometer upstream and 36 kilometer downstream in 7 hours, okay? That means if I say my upstream time, this is going to be 1 second. My upstream time plus the downstream time is going to give me together as 7 hours. So I'm going to represent the upstream time as T upstream plus T downstream, which is equal to 7. Okay. So this is what I have concluded from the first statement. In 9 hours, it can go 40 kilometers upstream. So in 9 hours alone, it can go 40 kilometers upstream and 48 kilometers downstream. If x represents the speed of the boat in still water in kilometer per hour and y represents the speed of the stream in kilometer per hour, then so these are the equations given to us. So from here, the first thing what could we say is that the speed of the boat is x and the speed of the stream is nothing but y. Okay. So boat has, let me just write it down. Speed of the boat is x and speed of the stream is y, correct? So from here, I could say that my upstream speed is always, I hope everybody is clear with the concept of upstream and downstream. It's nothing but upstream is when the boat is moving towards the opposite direction of the stream, and downstream is when the boat is moving in the same direction of the stream or water. Upstream speed is, since it is going in the opposite direction, so your speed of the stream is going to get subtracted from the speed of the boat. Okay. So my speed of the boat is x, so x minus y. So I'm going to consider upstream speed as speed upstream. And similarly, I'm going to consider my downstream speed as SD. Okay. My downstream speed is SD, and that's going to be x plus y as the boat is moving in the same direction of the stream. Okay, is that clear? Now, based on this, we are now going to frame some equations. Okay, so if you all notice here, a boat is going 32 kilometer. Now, we know the relationship that distance is equal to speed into time, or you could say that time is equal to distance over speed. Now we already have our equation 1, which says that the upstream time plus the downstream time is equal to 7, right? So from here, how do we write the expression for upstream time? We already have the upstream speed with us, and we also have the upstream distance. So the upstream distance I would represent with du, and the downstream distance I'll represent it with dd. Okay. So we have all the three quantities with us. All we have to do is frame expressions now. Okay. So the first expression would become, for tu, it would be, I'll write it down here, du divided by su plus dd divided by sd is equal to 7. And how did I get this? This is from equation 1 I'm getting, okay? Because t was nothing but the upstream time, and we know that time is equal to distance over speed. So distance of upstream over speed of upstream. Now based on this, I'm going to make my equation. Upstream distance was 32 kilometers and upstream speed was x minus y, plus downstream distance was 36 kilometers and downstream speed was x plus y, and this totally is going to give me 7. Okay. So I hope everybody is clear with this. Now from here, what are we going to do next is, there is another condition given to us. In 9 hours, it can go 40 kilometers upstream and 48 kilometers downstream. From here, can we frame out another equation? Tu plus Td is now going to give us a 9 hours of time. This is our second equation. Based on this, I'm again going to make my equation. So this time what's happening is my speed is constant. So all of these are speeds in kilometer per hour. These are all speeds in kilometer per hour. But what's happening is, this time my distance is changing. My distance this time is going to be, upstream is 40 kilometer over the upstream speed is x minus y, plus the downstream is 48 kilometers and the downstream speed is x plus y, and this is going to give us a 9. Okay. So this is our So I'm going to take this as my final equations. And from here, they are wanting us to find out x plus y and x minus y. Okay. Let me now clear up the whole whiteboard. Please make a note of all the things that I have written till now. And now we are going to solve about how do we go about this question. Okay. Everybody is clear till here? I think everybody must be understanding things better. And if any of you have doubts, please go through the concept of upstream and downstream and boats in stream from your school syllabus. Okay. All right. So I'm going to clear all of these. So we are going to write our final equations now. So we had got 32 over x minus y plus 36 over x plus y, which is equal to 7. And the second one was 40 over x minus y plus 48 over x plus y, which is going to give us a 9 here. Okay. Now based on this, it's very difficult to calculate the values of x minus y and x plus y in this way. So we are going to make some assumptions, that is 1 over x minus y could be taken as p and 1 over x plus y is going to be taken as q. Now based on this, I am going to rewrite my equations here. So 32 times of 1 over x minus y could be replaced by p and 1 over x plus y could be replaced as q. So 36q, which is equal to 7. Okay. And then we have 40p plus 48q, which is going to give us a 9. And I'm going to erase the rest of the things because these are not needed anymore. And now using these two equations that we have got right now, we are going to solve the value of x minus y and x plus y. Okay. So here goes our first equation. So I would go ahead with the elimination method or substitution method. So I have to decide on it. If I go with the elimination method, I have to find the LCM and do it. If I go by substitution method, I could simply take the value of p in terms of q and substitute in the second equation. Okay. So let's do that. Let's take the value of p in terms of q here. Alright. So from the first equation, I could say that 32p is equal to 7 minus 36q. And from here, p is going to give me 7 minus 36q over 32. Okay. And I'm going to substitute this value of p in our second equation in place of p. So now when we substitute this, we get 40 times of 7 minus 36q, which is going to give us, okay, over 32 plus 48q, which is going to give us a 9. And from here, I can cancel out 2 times 2, 20 and 16. And then this is going to be a 10 and 8, or you could say 4 times 5 is 20, 4 times 4 is 16. And from here, you could see that 7 times 5 is 35, right? So 7 times 5 is 35 minus 36 times 5 is 180q. Let me check. 6 times 5 is 30. 5 times, yes. So divided by 4 plus 48q is equal to 9. Okay. And now from here, I am going to go ahead and solve it further. I'm going to take the LCM. So when I take the LCM, I get 35 minus 180q, and 48 times 4 would give me how much? 8 times 4 is 32, 16, 17, 18, 19. So plus 192q is equal to 9. Okay. So from here, what can we say is, we can take this 4 times of 9 as 36. So 35 minus 192 minus 180 is going to give us a 12q, which is equal to 9. So from here, 9 times 4. From here, what could I say is 36 minus 35, and this is going to be a plus 12q. Yeah. So 36 minus 35 is going to give us a 1. So the value of q from here is nothing but 1 over 12. Okay. So once we have got the value of 1 over 12 as q, we are now going to substitute this in any of the equations. So we can substitute it in place of this itself, and we'll calculate for the value of p here. Okay. Please make a note of this, because we are now going to erase this and we are going to calculate the value of p. So the value of q is 1 over 12, and now we are going to go ahead and calculate the value of p from here. Okay. I hope everybody is understanding the steps here. It's a pretty lengthy question, but trust me, it's very easy. You have to just be focused on the calculation. Okay. So we had got the value of q as 1/12. So my p would become 7 minus 36 times of 1/12 over 32. So from here 12 times 3 is 36. So here we would be getting 7 minus 3, which is nothing but 4 over 32, and that's going to give us 1 over 8. So we have now got the values of P and Q. So P is 1 over 8 and Q is 1 over 12. So now from here what could we say is, we know that P was equal to 1 over X minus Y. And this itself is equal to 1 over 8. So can I say that X minus Y is equal to 8? Yes. Similarly, I can say that Q was equal to 1 over 12. So 1 over 12, which was equal to 1 over X plus Y. So from here, I could say that X plus Y itself is equal to 12. Hence, option A is the right answer to this. Okay, I hope everybody were clear with the question. So this was all about the boats and stream. With this, we are going to go ahead with our advanced problems for today. Okay. So here goes our first advanced problems. Everybody please have a look into it and then we would be solving this. Okay, so here goes your options as well, and let's quickly look into the question here. Okay, it says that so the ratio of a two-digit number to the sum of digits of that number is 4:1. So let's say that the two-digit number we have here is nothing but yx. Okay, let the two-digit number be yx. And from here, what could we say? That y is the tens place digit and x is the ones place digit. Okay. And the ratio of a two-digit number to the sum of its digit, right? So from here, first of all, how do we represent this number? We know that this number could be represented as 10 times of y plus x. This is how we represent a number. Because why do we multiply 10 to y? Because y is at 10th position. So this is the place value of the digit y, 10 times of y. We multiply the respective digit with its place value, which is 10 times y, plus x would be multiplied with 1, which is x itself. Okay, and the sum of the digits is nothing but y plus x. Now we know that this numbers ratio divided by, so let me just write it down here. This numbers ratio, which is 10x plus 10y plus x, divided by the sum of its digit is the ratio, which is 4/1. And also it's told if the digit in the units place is 3 more than the digit in the tens place. That means the units place digit is x and it is 3 more than tens place digit, which is y plus 3. So in place of x, what I could do is I could substitute y plus 3. So in equation 2, I'm going to write x as y plus 3 wherever I see x. So 10y plus y plus 3 is divided by y plus 3 is going to give us a 4. And from here, what could we do is, we have 10y plus y, which is 11y plus 3, divided by 2y plus 3, which is equal to 4. And then we are going to go ahead and solve this further here. So 11y plus 3 is equal to 4 times of 2y plus 3, which is going to give us a 8y plus 12. So 11 minus 8 gives us a 3y and 12 minus 3 gives us a 9. So y is going to be 9 divided by 3, which is nothing but 3 alone. So now if y is 3, what's the value of x? The value of x would be 3 plus 3, which is nothing but 6. And hence the number is yx. So yx is equal to, the value of y was 3 and the value of x is 6. So hence the value of the number is 36. I hope the question was clear to all of you and all of you did enjoy the question as well. With this, we are going to go ahead with the last question for today. So let's see. Here goes our last question. Please have a look, everybody, and please do give it a try and reply on the comment section about what you think on this question. Okay, let's proceed and try to solve this. So as we all can see, the denominator of a rational number is greater than its numerator by 3. Right? So denominator of a rational number. So let's say that the rational number that we have is a over b. Okay? And the denominator, that is b, is greater than its numerator by 3. That means numerator is a plus 3. and we could keep this as our first equation. If 3 is subtracted from the numerator and 2 is added to the denominator, that means this is our actual rational number. With this numerator, we are subtracting 3. From this numerator, we are subtracting 3 and 2 is added to the denominator. That is, we are adding 2 to this denominator. Then the new number becomes 1 over 5. Then the original number was what? So in place of b, we could substitute a plus 3. So a minus 3 over a plus 3, that is from equation 1 we are getting, plus 2, which is equal to 1 over 5. And from here, we could say that this is going to give us a minus 3 over a plus 5, which is equal to 1 by 5. And from here, we are going here. So a minus 3 times of 5, that is cross multiplication, is equal to a plus 5. So then next step would become 5a minus 15, which is equal to a plus 5. And 5a minus a would give us a 4a, and 5 plus 15 would give us a 20. And therefore, the value of a is 20 over 4, which is 5. And if a is 5, what is b? b is nothing but 5 plus 3, which is nothing but 8. So hence, we have got the value of a and b, and hence the rational number was a over b, the original number, which is nothing but 5 over 8. So hence, option C is the right answer. A very big round of applause to all the students and the participants who have been consistently answering on the comment section. Thanks a lot for attending the session. I hope all of you did enjoy, and this session is going to be very helpful for your preparation of IIT Foundation as well as Olympiad and regular school math. So with this, we'll quickly move ahead with our learning outcomes. So we have understood how to finding the values of variables for which LHS and RHS are equal, understanding how the equation has been solved step by step, and how to frame equations by carefully observing and understanding the words. So these are the key takeaways or the learning outcomes which we have seen from today's session. With this, I would like to wind up our session with the announcement of the Ultimate Cuemath Olympiad 2020, which has been launched by Cuemath, and this is going to be held in the month of November and December. So the link is there in the description box. Go ahead and click on the link and register today. The registration amount is just 200 rupees, and along with this, you would be getting a course curriculum of worth rupees 5,000 just for 200. Do not delay and hurry up and register today. Thank you so much.